All right, everybody, congratulations to making it to this point in the worksheet. We're on our final section here. Quite a few things that we're seeing coming up on this test, obviously. Last thing is properties of graphs of these rational equations. So two different types of asymptotes and some holes that we can look for. Remember the vertical asymptote, we take our denominator and set it equal to 0. So denominator is a term on the bottom, x minus 5, set it equal to 0, and we solve. Add 5 to both sides, we end up with x equals 5. So we have a vertical asymptote at x equals 5. So on a graph, if we're looking at this, we go to where x equals 1, 2, 3, 4, 5, and we know that our line cannot cross at that point. Next, horizontal asymptotes. There's a bunch of different things we need to look at for this. If the degree of our numerator is less than our denominator, we have y equals 0. In this case, our degree of our numerator is greater than our denominator. A reminder, if the degree of the numerator equals the degree of the denominator, we have y equals the leading coefficient divided by the leading coefficient in terms of leading coefficient of the top divided by leading coefficient of the bottom. And then lastly, if our numerator is greater than our denominator, specifically by 1, we have a slant horizontal asymptote, and we have to, in order to find that, actually do some division. So we divide the numerator by the denominator. If the numerator is bigger than the denominator by more than 1, we actually don't have a horizontal asymptote. In this case, we see our degree here. We can label this, maybe we'll do it in red. Degree of the top is 2, degree of the bottom is 1. We have 1x or 2x's on the top. Because of that, our numerator is 2, denominator is 1, their difference is 1. So numerator is greater than the denominator by 1, which means we have to do some division. So we end up with the question x squared plus 4x plus 7 divided by x minus 5. So we can do some synthetic division for this. If you remember, we take this term, we put the opposite of it in our box. We take our leading coefficients and write them one by one, making sure we don't skip any degrees. And then we follow the steps. Bring the first term down, multiply it by the number in the box. Combine those terms, multiply it by the number in the box. And then we're left with our remainder, our constant, and then our first degree. Keep going up in that order. So our answer to this one is x plus 9 with a remainder of 52. We don't care about remainders in this case. We just actually use that x plus 9 as our equation. So actually, you have permission for horizontal asymptotes specifically to ignore your remainder, and your equation here is y equals x plus 9. So this is also an asymptote that your function cannot touch. The last thing we are looking for, holes or things that we can cancel or that equal each other on both the top and the bottom. So for this one, we're going to have to do some factoring of our top. If we see here, we have x squared, 4x, and 7. Let's see what we have for 7. 7 and 1 are our two options. Can't multiply anything else to get 7. Looks like those add up to get 8. And that's actually not going to work here. So we're not going to be able to factor in this case, which is okay. Sometimes that happens. So it looks like we have no holes, nothing that cancels on the top and the bottom. So no holes in our function. So these are going to be the types of questions that you're going to be asked on the test. You're going to have to identify those asymptotes, see do you have anything that equals itself on the top and the bottom. And then after that, you're going to use, either you can plug it in by hand or use some graphing function to see, based off your asymptotes, where is this graph going to live on the actual diagram there. All right, everybody, thanks for tuning in. Hopefully this review helps. As always, if you need any extra support, reach out, message, email, any of those things. We are